Goal 7, Lesson 6, Kites. What we're going to be learning in this section is just more properties of various quadrilaterals, specifically the kite. You are going to have to know how it relates to other shapes, so things like an always, sometimes, never statement, and then finally use those properties to find missing parts of a quadrilateral or of our kite. What makes something a kite? A kite is a quadrilateral with two pairs of consecutive sides congruent. So when we draw a picture of our kite, we're going to mark one pair of sides that's next to each other with one tick mark. The other pair of sides that are next to each other will use two tick marks. So it's not all consecutive sides, just one pair, and then the other pair of sides is congruent. We have four properties of a kite that you have to know. The first is the angles add up to 360 degrees. You should remember this for all of your quadrilaterals, but we use it a lot with kites, so that's why we're writing it again here. The second property is what we just marked, two pairs of consecutive sides congruent. Consecutive, remember, means next to. The third property is one pair of opposite angles congruent, and the key there being only one pair. That's what makes this very different from our parallelograms and other shapes. It's important in your picture that you mark the correct pair. When you mark the angle, it should be touching a side with one and two tick marks, and then go opposite that, it's touching the side with one and two tick marks. If we draw in one of our diagonals, what you'll notice is you have two congruent triangles. That's why those angles are congruent. All three sides are the same. The final property of a kite is the diagonals are perpendicular. So if we draw our other diagonal now, we can put that box in the middle to show that we have four right angles. It's very important though, it does not cut those angles into two congruent pieces. The entire angles are what's congruent. Here's our first example. Go ahead and pause the video, try solving for x and y, and then watch and see if your answer is correct. First, we're going to solve for x. We know that we have one pair of opposite angles. Again, it's very important that you mark this correctly. I'm going to put a swoop in between a side that touches one, an angle that touches one and two markings, and the other angle. Those two angles are the same, so x is 104. Go ahead and put 104 back in your picture to help you find your other angle. To solve for y, we don't know anything about the opposite angle, but we know three of the four angles. So we can use the fact that the four angles of a quadrilateral add to 360 degrees. 104 plus 104 plus 38 plus y equals 360 degrees. When you combine like terms, 246 plus y equals 360. Subtract 246 from each side, and you get that y is 114 degrees. Here's your next example. Again, pause the video, try and solve for the angles marked x and y. To start off with, we're going to solve for x. If you notice, those are two diagonals intersecting. One of our properties is that those diagonals is perpendicular, so we know that x is 90. To solve for y, we're going to use a triangle. The equation we can write, y plus 90 plus 32 equals 180. So combine like terms, so y plus 122 equals 180. Subtract 122 from each side, and y is 58. Copy down this last example and solve for x. 5 and 12 are labeling the small segments. If you remember in our last example, we know that the diagonals are perpendicular or form a right angle. We can use Pythagorean theorem looking at that triangle to solve for x. So a squared plus b squared equals c squared, or leg squared plus leg squared is hypotenuse squared. One of our legs is 5, the other leg is 12, and we don't know x or our hypotenuse. 5 squared is 25, 12 squared is 144. Combine like terms, 25 plus 144 is 169. And square root each side to solve for x, you get 13.